right, this is Algebra 2, Lesson 106. We have more on a system of 3 equations. So every equation does not have all 3 variables. But you have to write, when you write the equations, line up your variables, and then you have to decide which variable you want to eliminate by using all 3 equations. Okay? So like example 1 on page 437. We have x and y, but no z. I'm going to leave a space for z, because this is going to help me decide which one I want to eliminate. In the second equation, I have x and I have z. And in the last equation, I have y and I have z. All right, so I can either choose to eliminate x, and I end up with y and z, and I have y and z in this one, and then I can deal with those. You following me? I can decide I'm going to take the first 2 and I'm going to take the last 2 and eliminate z, and then I'll have x and y. So those are my 2 options. I could eliminate any. I could eliminate x. I end up with y and z, so I have this equation and this equation. I could eliminate y, then I have x and z. Or I could eliminate z, and then I have x and y. Which one do you want to eliminate? X, y, or z?
Z.
That's what I want to eliminate, is z, because I just multiply this by -2 to make that a +2. Then I'm going to add it with this, and I'll just have x and y, and then I'll look at it. You see how this is just a little different from what we've already worked? It's just slightly different. All right? So I end up with -4y plus 2z is +12. Then I have x minus 2z is -3. So that's what I end up with. My z's eliminate. I end up with x minus 4y is 9. So now I have equation A and this new equation. What do you want to eliminate? What do you want to do with these 2 equations? You want to eliminate x. That's what I want to eliminate. You could use substitution. My preference is elimination. So I'm going to multiply this equation by -2. So that I'm going to rewrite this first equation, multiply this one by -2, so I have -2x. That's going to be plus 8y equals -18. My x is eliminated. So I have, what is that, 11y equals -22, not 32. 22 dividing by 11, y is -2. All right, so I have one of my solutions. Okay, what would you do from here?
Substitute y back in.
Where?
Second equation over. No, that's not y.
-4y plus.
Go back to the originals. Either we're going to substitute it in this one and solve for x, or we're going to substitute in this one and solve for z. Which way do you want to go? You want to solve for x or z? Z. Okay, so we're going to substitute in here. So it's 2 times -2 minus z equals -6. I'm going to add z and 6 on both sides to move them. Everybody see that? I'm going to add z and 6. So it's negative 4 plus 6 equals z. Z is positive 2. Now we want x. Which equation do you want to use to solve for x? You want to use the first one? You could. I probably want to use the middle. Doesn't matter. I'm going to use the middle. X minus 2 times 2 is negative 3. That's 4. I'm going to add 4 to both sides, so x is 1. All right, so the solution is 1, negative 2, 2. Now let's just make sure that works. So that's 1, negative 2. 1, negative 2. You just go back and check. So that's 2 minus 6 is negative 4. That works. That's 1 minus 4 is negative 3. That works. That's negative 4 minus 2 is negative 6. It works for every equation. So it's easy to go back and check to see if your solution is correct. All right, so just make sure when you write your equations, line them up and then decide what you're going to eliminate. All right, there's one more example. Okay, I have one question. What does that represent? What does 1, negative 2, 2 represent? X, Y, Z coordinates, okay? But we have 3 equations. What does this point represent?
The y coordinate.
The y-intercept.
Not the y-intercept. That's where the 3 equations are concurrent. It's where the 3 equations intersect. That's why when you're solving for x, y, it's on a 3-dimensional system, obviously, right? 3-dimensional graph. That's when you're solving for x or y. Like when I have x squared plus y squared is 5 and I have 2x squared minus y squared is 6, I can't just say x is plus and minus 3, y is plus and minus the square root of 3. Because what does that tell me? What am I asking for when I'm asking you to solve this? I'm asking, where do these 2 graphs intersect? This doesn't tell me where they intersect. You give me a coordinate pair, 3 comma square root of 3, then I know that's where they intersect. The x, y coordinates where they intersect. You got it? Does that make sense? All right, let's do the other example. And line up those x's and y's and z's. All right, here we have a y and a z. So we have 3y minus 2z is negative 12. The second equation is 2x minus 3z is negative 5. Then we have x minus 2y equals 6. All right, what do we want to eliminate? Let's go over here. Ladies, what do y'all want to eliminate? X, Y, or Z? Y'all decide. This area decides. X is what I would want to eliminate. And then I'm left with Y and Z. So I'm going to use the second 2 equations. I'm going to multiply this equation by negative 2. So rewriting this equation and multiplying, and when we multiply, it's got to be by every term. I know simple mistakes are made, and I'm telling you 100% of the time when simple mistakes are made here, it's because you didn't multiply by what's on the other side of the equal sign. All right, so we end up with negative 2x plus 4y. I mean, even I make the mistake sometimes. So then we have 4y minus 3z is negative 7. Now I have to use the first equation and the new equation. All right, so what do y'all, yes,
Is it -7 or -17?
it's negative 17. Yeah, thank you. Negative 17. Yes, thank you for telling me quicker, sooner than later. Totally ignore that negative by the 5. All right. Now we have these two equations. What do y'all want to eliminate? Y or Z? In the middle, decide. Y or Z? Z? Does everybody vote for Z? That's what I would vote for. They're the smallest numbers. All right. So I'm going to multiply this one. I'll just make that one a negative 3. I'm going to multiply this one by positive 2. Make sense? So we end up with negative 9y plus 6z equals positive 36. This one, when we multiply by 2, we end up with 8y minus 6z equals negative 34. This one's easy. Negative y equals 2, y equals negative 2. All right, we're writing them as a coordinate, as pair. Gotta go over some. So that y is negative 2. All right, now we've got y. What do you want, guys? What do y'all want to solve for next? We have y. You want to go x or z next? X? Okay. All right, so we're going using this equation. X minus 2y, God bless you, equals 6. That's positive 4. That's an X. That's positive 4, so we're subtracting 4. X is 2. Now we'll go solve, almost said y, solve for z. And I'll go back to this first equation to solve for z. All right, so I'm using the first equation to solve for z. So 3 times negative 2 minus 2 times z is negative 12. That's negative 6. So I'm going to add 6. So we end up with negative 2z is negative 6. So z is positive 3. All right, let's see if this works. All right, so that's negative 6 minus 6 is negative 12. All right, so that's 4. 4 minus 9 is negative 5. That's 2 plus 4 is 6. So it works in all of them.